Okay, so here's a little problem for you. Maybe start our last little topic. I'm giving you 2 points in the plane, okay, A and B. Remember, points, they're labeled with capital letters usually. And I'd like you to find, let's say, the midpoint. The point that's right in the middle. Midpoint. Okay? How are we going to do this? So maybe you want to work with a little example first just to get some intuition. So maybe I have the point, I don't know, 1, 2, and this is 3, 7. What would be the point right in the middle? Okay. And if that's too complicated, okay, here's an even simpler problem. I'm giving you on the real line two numbers, I don't know, 7 and 2, and I'd like you to come up with the point that's right in the middle. And if you can solve that problem, try to solve a more abstract problem where you're given 2 points, A and B, and you want the point right in the middle. How are we going to get those? Like, can you get, eventually I'd like you to solve this one. Can you give me a formula for the midpoint, the one that's right in the middle of A and B? So think about it, and so think about all these specific examples here, this one, and maybe eventually this one, and try to come up with an answer. So pause the video and come back. So often, okay, let's look at this problem right now. That's the easiest one. Often the answer I get from students is 7 minus 2 over 2. Okay, you can try to convince yourself that that doesn't work at all. Okay, 7 over 2 minus 2 over 2, that's 5 half. That's 5 half. That's if you want in decimal, that's 2.5. 2.5 is going to be somewhere here. You can see that it's really not in the middle. Okay, so that doesn't work. And it doesn't work here. Of course, the formula is not b minus a over 2. That also doesn't work at all. Okay, the correct way to think about to think about what the midpoint is, think of it at first as an average of the 2 points. Okay, so in fact, if you think about it as an average, then you can see clearly what the formula is going to be. If I want to take the average of 7 and 2, I need to add them up and divide by 2. And in that case, if I do this, I get 9 half, which is 4.5. That's actually right in the middle. You can check. So the correct formula here is b plus a over 2 or a plus b over 2. It's the same thing. Okay, so that's how you get the midpoint. Now, I think the confusion, okay, why are students doing 7 minus 2 over 2? Because they're saying, okay, 7 minus 2, that's this length, and I will take half of it. But they forget that the initial point is not the origin. So if you take half of the distance between 7 and 2, you're not considering the fact that your midpoint is in between 2 and 7, so it needs, I mean, you need to add that length to 2. You're not starting at 0. Okay, so if I would start at 0, if I have, I don't know, maybe 7 instead, okay, here, okay, so the midpoint right now, yes, that's 7 minus 0 over 2, but that's because I'm starting my left-hand point is the origin. If it's 2 now, that technique doesn't work. I cannot do this. I cannot replace the 0 by 2, and it will not work anymore. So what I need to do is half of the length, I need to add it to 2. Okay, that's, and let's check that we're going to get the same formula. So if I add it to 2, let's write everything over a common denominator. I get 4 plus 7 minus 2 over 2. That's what is that? That's exactly the same as 7 plus 2 over 2, right? That's 11 minus 2, 9. 7 plus 2 is 9. So now it works. So if I do this, it works. Okay, So the approach I've used here, so I'm gonna so adding half the length to the first point, okay, that will work also in the plane. Okay, so let's come back to our general problem. So we're given a point, I don't know, with coordinates, maybe this is A1, A2, and B with coordinates B1, B2, okay? And I'd like to get the midpoint. Okay, let's run a line here. I want to get the midpoint. Well, imagine the origin is here. Okay, so here's how we're going to do this. I need a color. Okay, I'd like to get to this point here, essentially. Okay, so this point here, it has the same coordinates as the vector starting at the origin, ending there. Now to get to this point, I'm going to follow a path. The path I'm going to follow is I'm going to get to A first. So that's kind of the same thing as having our 2 here. So I'm going to first compute vector OA. Okay. And then I'm going to imagine there's a vector here. That's AB, right? Now AB, I want to actually not go all the way from A to B. I want to do half of that. Half of AB. And then I'm going to add it. So this is the part that matches this in with vectors. That matches this part here. And the 2, it matches this part here. So what's OA? OA is A1, A2. OA is the vector that ends at A, it starts at 0, so it has the same coordinates as our vector, as our point A. Now, AB is a bit more tricky though, okay? So what's AB? Maybe I'm gonna draw AB in a different color, maybe in blue. Okay, so that's AB here. Whoop, here we go. That's AB. How do I get AB? What I want to get, I want to get AB based on the coordinates of A and B, okay, of points A and B. So that here's the thing we have to notice here. So I'm going to use another color. So this is OB. This is OA. Okay. Now AB is the vector that goes from here to there. Now I don't know if you remember, but we had something like this when we had, I don't know, a vector u, a vector v, and we had a vector going from the head of between the head of the vectors. And what was this vector? It's the vector v minus u. We can check again if you're not sure. V to which we subtract u. So we subtract u, we're going this way. So v minus u is this vector, v minus u, and yes, it matches exactly this one. So to get AB, what do I need to do? I'm going to apply this little trick here. It's kind of a little formula. AB is what? It's the vector. It's the position vector that matches the coordinates of the endpoint of my vector AB, so B. So that's the vector OB. And I want to subtract OA. So that's kind of like my V minus U that I'm doing here. Okay. So this is actually, so along the way we're finding something that's kind of important. This is an important result actually, to get to get a vector, the coordinates of a vector starting at A, ending at B, you do coordinates of B minus the coordinates of A. That's essentially what you do. So let's write this up. Coordinates of B, so this is B1, B2, minus the coordinates of A. And okay, all right. So I've got A1, A2. So what I'm trying to get, to do now is simplify this a little bit. Now I've got a scalar 1/2 that's multiplying a sum or a difference of vectors. So I'm going to distribute the 1/2. Now you'll notice that this and this are very similar, right? This is 1 times the vector a1, a2, minus 1/2 times the vector a1, a2. So that's 1 minus 1/2. That's 1/2 times the vector a1, a2. It's 1 times the vector minus 1/2 times the vector. We get 1/2 times the vector plus 1/2 times the vector b1, b2, because this is this part. I'm not doing anything with it. I'm just recopying it down. And eventually what you can write it up this way: a1, a2 plus b1, b2. We can even write divided by 2 or times 1/2. Okay, so what do we get here? So this is our midpoint. This is a formula for the midpoint, and we get something that's very, very similar to the formula we had before. Remember, the formula we had before was this for when we had two numbers, a, b. Well, it's the sum of the numbers divided by 2. Well, here it's exact same thing. Whoop. I'm trying to move this. Okay, we get the exact same thing. We get the sum of the vectors now divided by 2. So this is one way to think about this. Is it's the average again of the vectors, and that's how you get the midpoint. So maybe example. Let's say I have I don't know, 1, 7 and minus 3, 4. Well, the midpoint, that's easy. It's going to be the average of the sum of the two vectors. So it's going to be 1/2, 1 minus 3 minus 2, 7 plus 4, 11. So that's going to be the point minus 1, 11/2. So that's 5.5. And that's the midpoint. Okay, now let's try to solve a even more general problem. I've got again point A, point B, and now I want to get to a point. Okay, let's join this by a line. That's, I don't know, maybe it could be 2/3 of the way between A and B, or it could be 1/3 of the way between A and B. Okay, so the fraction will be represented by what we call usually a parameter. This is lambda. It's a Greek letter. Okay, so it's just some variable, but lambda could be example. Lambda could be 1/2. That's the midpoint, right? It's when you're half of the way, but lambda could be, I don't know, 2/3. Lambda could be 1/3, or it could be your favorite number between 0 and 1. So this way we can generate a point between A and B, all points actually between A and B. So how do we do this? Well, it's the same principle. Imagine the origins here. Okay, to get to this point, okay, all I need to do is calculate the coordinates of this position vector. Okay, how am I going to do this? Well, I'm going to go along, well, this path. So I'm going to go to A first. That's easy. I'm going to do O. So I'm going to give this point a name. I'm going to call it point Q. Okay. So I want to, point Q has the same coordinates as the vector OQ. So OQ will be what? I'm going to go to A. So OA. And I know the coordinates of A because they're given to me. And all I need to do is, instead of, let's backtrack a bit, instead of doing 1/2 of AB, in this case it's lambda times AB, because it's a proportion of AB, and it's not necessarily a half. It could be, like I said, 1/3 or 2/3. Okay, and we get a similar formula as before. So AB is what? Well, it's OB minus OA. Okay, that's the formula we have from before. And I'm going to distribute the lambda. Whoop, there's a minus sign. Okay, And now I've got OA and minus lambda OA. So what is that? That's 1 minus lambda OA. So that's 1 minus lambda OA plus, I'm sorry, I just switched color. Doesn't matter. Plus lambda OB. And that's it. So what I have here, I have scalars. And what I have here, so those are scalars and those are vectors, right? Well, they're actually position vectors. So they're actually also points in some way. But what's interesting is I have here a linear combination of the points A and B, of points A and B. So with this, you can generate all points. So what would be the value of lambda that generates point A? Well, to generate point A, let's look at the formula. I want 1 times OA and 0 times OB. So lambda is actually 0. If I want point B, what's the value of lambda? I want 0 times OA. So 1 minus lambda must be 0. So lambda must be 1. And 1 times OB, yes. And the midpoint is when lambda is a half. Okay? So when you want to generate any points between points A and B, lambda is going to be a value between 0 and 1. If it's a third of the way, lambda is a third. If it's 2/3 of the way between A and B, lambda is 2/3. Okay, and that's it for section 3.1.